Hi, my name is Halima Shaman, and I'm going to be talking about what material is best for NASA, and here we go. So, from what I understand, you need material to make the tiles of your shuttle, and according to you, they need to withstand heat of reentry, withstand the impact of space debris. And your constraints are $15 million, so let's get on to it. Okay, so the physical properties, so in order to have those features available for you, the physical properties of the material should have, or should be non-magnetic, a high melting point, a high hardness or strength, a high malleability, and a low density, in order for it to be light. So these physical properties of interest mean, based on the physical properties of interest, you want a material that will sustain heat and can withstand impact and is light or less dense in a scientific term. So the chemical properties for this material need to be not dissolvable, so when it's in contact with water or air, and it doesn't have to burn, it shouldn't burn, which is the high melting point. So in order to choose the right material, we have 4 different types of material here, so metal, polymer, wooden fibers, and ceramics. And based off of these, we can tell how much the hardness is. So metal has a pretty good range of hardness. Polymer, it doesn't seem like the best choice because it's only up to 7, and neither is wooden fibers. And also another main important property is the melting point. And based on this, you can see metal again has a high melting point and a good range, and so is ceramics, but not polymers and wooden fibers. So when we eliminate the materials that wouldn't be right for what you need, metal, the hardness is high, but the melting point, it does have a good range, but it is too low for withstanding the heat of reentry and making sure that the astronauts aren't boiling inside the shuttle. And polymer, it's not hard at all, so it's not going to work, and it's not going to withstand the impact from space debris, and the melting is way too low. And wooden fibers, we can take this out of the pool automatically because it burns, so it's not an option. Ceramics has a high hardness and melting point, so I think this would be the best material for you. And with the high hardness and melting point, it is less dense than metal, which is why it will work better than metal. So the specific material based on the ceramic category selection. So after hours and hours of researching, I finally found the perfect material for your needs. And that material is silicon nitride, Si3N4, which is silicon and nitrogen combined together. And the properties of silicon nitride is high thermal shock resistance, low density, high hardness, and low thermal expansion. So this all together will add up to become the best material in order to make your tiles. So what it looks like and feels like, it's gray and it's an odorless powder, but it can be made into a solid, so it can be shaped into the tiles you need. The density is 3.2 grams per centimeter cubed, and that's when it's a solid. And the melting point is 1,900 Celsius or 3,450 Fahrenheit, which is very important because once you come into the Earth's orbit or leave Earth's orbit, that is very important, so then the astronauts are safe and the space shuttle doesn't come apart. So, based on the silicon nitride, I created a model for you. So the chemical formula, first of all, is Si for silicon, 3 and nitrate 4. So Si 3 and 4. And the model is basically, so based on my calculations, as silicon nitride is a polar covalent bond, which explains the close molecules together. And over here, with the polar covalent bond, it means the negative electrons, there's more negative electrons than positive electrons, which this part shows. And once we combine these two, we get our model, which shows 3 SIs because it's Si3, and 4 Ns combined to form a polar covalent bond. So this helps keep the material hard and less dense. Okay, so the intramolecular and intermolecular forces associated with the important properties. So once again, it's a polar covalent bond. The electronegativity is 1.24, which is how we knew it was a polar covalent bond. We knew this by taking the electronegativity of silicon and nitrogen and finding the difference, which is 1.24. And we also know that nitrogen has 20 electrons and silicon has 12 electrons. So that's why in this model, the negative is the nitrogen, which is the blue right here, and the positive is the green. So the small ones is the silicon, and the blue ones are the nitrogen. So it shows like it's bigger because it has more electrons. So based on the model, we know that it has a high hardness because the molecules are tightly bonded. So it's hard for the molecules to break because they're so tightly bonded. So if you try, look, they're so like close together, so you can't. So it also has a high melting point because the molecules are tightly bonded, which makes it harder for the molecule to move faster to create heat. So if you had a molecule, and say like molecules in my hands, like it's so tightly bonded together, and the molecules that make up the object cannot like move, and it cannot generate heat because it's a solid, and it's harder because the bond is closer and tight, so it's harder. And it's also less dense because even though the molecules are tightly bonded, they're still spread out. So if I show you again, they're spread out. The bonds, instead like this one, when you combine this and this, you can see they're more spread out, which means it's less condensed. So to sum up, silicon nitride would be the best material to build the tiles for a space shuttle because of the high strength, melting point, and it is less dense. So there you go, and hopefully this will allow you to make a very good choice.